Hello everyone, welcome to my YouTube channel. Today in this video I'm going to dive into the world of mathematical function. So now I'm going to start with with a brief introduction to functions. So that just to remind ourselves what are functions. So now what is a function? Now in simple terms you can say that a function is a relationship between x and y, precisely one value of what of y for each value of x. So now what do they mean by this? They mean that the ratio of y is to x, it can either be what 1:1 or 1:2 or 1:3 and so on. So now those are the acceptable ratios for our uh, y is to x. So now if we have those ratio, then the relation between x and y, it is what? It is a function. So now if one value of x has two or more values of y, then the relation is not a function. Let's say the ratio of y is to x is what? Is 2:1. Then that relation between x and y, it is not a what? It is not a function. We cannot have two values of y for each value of x. No. So 2:1, 3:1, it's not acceptable for our function. So now a formal definition, we can say that a function is a relation between a set of inputs and outputs. So now our inputs can be what? Can be x. Then our output, we can say our outputs to be what? To be y. To be y values. So now here is an example of a function which reads as follows. It says f of x is equal to 2x plus 1. So now in this equation, what is our input and what is our output? Now f of x here, it is our output. Then x, it is our input. So now this f of x is in terms of x. So now it means x, it is our input, then f of x, it is our output. So now f of x, we can say that f of x represent all y value. It represents all sets of y values. So now we can say f of x equals to y, which is equals to what? 2x plus 1. So now f of x or y is what we call our output. Okay, now that's an example of a function. So now for function, we have different types of functions. Now we'll start with the simple, which is a linear function. So now a linear function is represented in this form: f of x equals to mx plus c. So now this is a formula for our linear function. So in this equation, m represent a what? A slope. M represent a slope, then y. Then y, it is our y-intercept. So now, since while m it is our slope, then m it is the one that can determine the shape of our of our graph. So now if we have a negative if we have a positive, let's say positive gradient or positive slope, now if we have a positive slope, then it means our graph will be an increasing function like this one. Okay, so now if we have a negative slope, then it means our function our graph will be a decreasing function like this one. So now that's how simple linear function it is. So now moving on to another type of function. Here we have a quadratic function. So now you can represent a quadratic function in three different forms. Now we have this form whereby it says f of x equals to ax squared plus bx plus c, and then ax here, it will be the one that will be it will determine our shape for our graph. Then b and c are our constants. And we have also this form of quadratic formula which says f of x equals to a into x minus p squared plus q. So now this form is what we call a turning point form. Now if we call it a turning point form, now what is our p and what is our q? Since while a it is the one that will determine the shape of our graph, then now what is our p, then what is, and also what is q. Now p here, it will be an x coordinate of what, of our turning point. Then q will be what, q will be our y coordinate of what, of turning point. So that's why it is called a what, a quadratic equation in a turning point form. Here's another form of quadratic equation which says f of x equals to a into x plus x minus p into x minus q. Now this equation, it is in a root form. So now why are we calling it in a root form? We are saying it's in a root form whereby a will, we have already said that a to 2, it will determine the shape of our quadratic function. Then p and q, what is our p and also q? P, it is it is an x coordinate of one of our roots. Remember that for our roots, our y coordinate for our roots, it is equals to 0. So now we have two roots here. So now both two roots, their y coordinates will be equals to what, to 0. Then p will be one of x coordinate of those roots, and also q will be one of those roots. Now that's why we say this equation is in a root form. So now we can determine the roots of our function. So now, just like I've already said, a determines our shape. So now how does a determine our shape? So now if a is negative, if a is positive, this is how our function will look like. This is how our function would look like if a is positive. But then if a is negative, then this is how our graph, let me say, our graph will face downwards. Then if a is positive, then our function will face upward. So that's how a determines our shape of our quadratic function. Now moving on, we have hyperbola. So now a hyperbola can be represented in a form whereby we say f of x equals to a divided by x minus p plus q. Now what is a, p, and also q? So now, like a quadratic function, a determines, okay, let me do this first. Okay. A determines our shape of a graph, of our graph. So now a determines our shape. Then p it is a horizontal. We can say that p, it is the one that, okay, p is our horizontal shift, or it is our vertical asymptote. So now p is a horizontal shift, or it is a vertical asymptote. Then q will be our vertical shift, whereby we shift our graph upward or downwards. Then it will also be a horizontal asymptote of our hyperbola. Remember that for a hyperbola we have two asymptote, which are vertical asymptote and also vertical asymptote. Now P will be a vertical asymptote, then Q will be a horizontal asymptote. Now, how does A determine our shape of our hyperbola? If A is positive, then it means our graph will sketch our graph at the first quadrant and also in our third quadrant. This is how our function would look like if A is positive. But then if A is negative, then it means our function will have to draw it in the second quadrant and also in the third quadrant. So that's how A determines the shape of our hyperbola. Now moving on to another one, which is the exponential function. Now the exponential function, we can represent the exponential function in the form of f of x equals to a multiplied by b to the power of x minus q. So now, what does a here represent? Now a represent a constant, whereby b represent a what? A base of x, and b determines a what? Determines our shape. So now for exponential function, it's either it is decreasing or it's an increasing function. So now that's where now p comes in. So now p will determine if whether our exponential function it's a decreasing function or it's an increasing function. So now q will be our vertical shift, just like other functions such as the parabola and also the hyperbola. Q will be what? Will be our vertical shift, shift or the horizontal asymptote. Now for exponential function, we don't have the vertical asymptote. We only have the horizontal asymptote, which is Q in this case. So now Q will be our vertical shift or horizontal asymptote. So now how does B determine our shape for exponential function? Sorry about that. How does B determine our shape of exponential function? Now, our B will always be greater than 1, will always be greater than 0. So now, if B is greater than 0 but less than 1, maybe let's say, for instance, say B is equals to a half. A half is greater than 0 and also it's less than what? It's less than 1. So now how will our exponential function look like? So now if b is greater than 0 and less than 1, then our function will be a decreasing function. So now our function will look like this thing. So now our function will be a what? A decreasing function. Now if b it is greater than 1, if b it is greater than if b is greater than 1, then our function will be an increasing function. That's when b is greater than 1. So now, what if our b it is equals to 1? What if our b it is equals to 1? Then if it is equals to 1, remember that if you raise 1 to any number, it will always remain as what? As 1. So now if b it is equals to 1, then our function will always be constant. That's where b it is equals to what? It is equals to 1. Okay, so now moving on to another one, we have a cubic function. So now a cubic function, we can represent a cubic function in this form, whereby we say f of x equals to ax cubed plus bx squared plus cx plus d, whereby a, b, c, and d are our constants, but a will determine the shape of the graph. So now how does a determine a shape of our graph. So now if a is negative, this is how our function would look like. For a cubic function, this is how our function would look like if a is negative. But then what if it is positive? Then if a it is positive, then this is how our function will look like. This is how our cubic function would look like if a is positive. So that's how a determines the shape of our cubic function. Now lastly, we have trigonometric function. Now for trigonometric function, we all know the function of sine x, we all know the function of cos x, and also tan of x. Now I'm gonna draw the one for sine x, then the other one you can draw them on your own. So now we have a function of sine x. So now a function of sine x, remember that this will be 90, 180 degrees. So now this is how, let's say this is 1 and negative 1. Now this is a function of sine of x. Now you can draw the function of cos of x, and also you can draw a function of tan x. I believe that you guys know how to draw these functions because you have already done them in grade 10. So now those are our functions. So now in the next video, I'm gonna start doing problems based on the function. I'm gonna start with for linear function and also parabola.